Hello and thanks for tuning in to our final installment of our Pinewood Derby car design challenge thing. My name is Jason Wedig, work out of the Columbia, Maryland office, and basically what I set myself a task to do was design the world's most awesome Pinewood Derby car. Now in order to do that I needed to start somewhere. So naturally I went to the internet because I needed to figure out the size of a Pinewood Derby car. After getting the proper dimensions to create the block, to create the body for my Pinewood Derby car, which I think looks really awesome, I then went ahead and I had to optimize certain aspects of it. Those aspects, first and foremost, would be the center of gravity. Now what I wanted to do with this particular car was design it so that way it would go the fastest down the ramp. That way I could win lots of races and brag to all my friends that I was awesome at something that 10-year-olds do. But anyway, Pinewood Derby car, adjusting the center of gravity, shouldn't be that hard. So I used a design study tool inside a SOLIDWORKS Simulation Standard to adjust this lead weight inside the vehicle to give me the optimal CG location of 0.75 inches in front of the rear axle. Now that worked out great. I was able to do that. But now I need to test my Pinewood Derby car to make sure that it is in fact the fastest Pinewood Derby car out there. Now, I built a ramp. So I went online, found the dimensions for the ramp, built it out of aluminum, and voila, we have it here on the screen. Now naturally, in order to test the speed of the Pinewood Derby car, I need to put the car on the ramp. A third assembly will illustrate that the car would be placed on the ramp. Now you can't really see it because we're kind of zoomed out. I put it in a pseudo room here. I figured green, I don't know, look cool. Now what I wanted to do here was do a motion study. Now in the motion study, I don't have any fancy propulsion devices. So for the Pinewood Derby car itself, which is still transparent, let's go ahead and fix that real quick. I don't have any, ion motors or DC motors that are propelling it down the ramp. The force of gravity is going to propel my car. Now gravity, in this case, is going to point down to pull the car down the ramp. Makes sense. So I set up my gravity constraint, and you can see the little green arrow over here indicating that gravity is pointing down. I also set up a couple of contact sets. Those contact sets are between the plastic wheels and the aluminum ramp. Those solid body contacts are going to basically define the frictional coefficients as my car goes down the ramp. I want to get accurate results here. I just don't want to get all willy-nilly and get crazy stuff. Now one thing you might have noticed is I went down to the motion study tool, but I'm not in the animation section. I'm actually in motion analysis. Once you've set up all your constraints inside of your motion study, you need to calculate it. This is where it physically does the physics behind the scenes. Let's go ahead and take a look at this study. We're going to run down the ramp. The car's going pretty quickly here, even though we're showing it at 0.25 speed. And we get to the end, and oh my goodness, there's another ramp at the end of the ramp. And looks like we crashed into the wall there. That was pretty exciting. Let's watch that again. Car's going down the ramp. We're picking up some speed, hopefully. Going on a little flat stretch here, up to the very end, and zoop, right off the end of the ramp. Hits the ground, bounces off the ground, and crashes into the far wall. That's pretty cool. I'm going to have to say that if I were a kid and my car went off a ramp at the end of my Pinewood Derby run, I'd be really excited, and then I'd probably be sad because it would break. Alright, let's stop that right here. And how do I know that the car is going faster as I go down the ramp, and what's my maximum speed? Well, I set up a plot here, and this plot is physically going to show the linear velocity of my car as it goes down the ramp. And it looks like we reached a maximum speed of 15 foot per second. Pretty neat. What's this red bar here? Well, that red bar is physically corresponding with the bar here in my motion study, letting me know at what step I'm at inside of my study. So we can see we get a very nice constant linear velocity improvement. We get to the top, it's reaching its maximum, and then it goes off the jump. At the top of the arc, what I like to point out here, which is pretty neat, is at the top of the arc of the trajectory when it leaves the bottom of the ramp, you can see it's at its lowest point there. So you can actually track the velocity, and then it hits the ground and it suddenly slows down a lot more. Pretty neat stuff. So I was using the motion study tool built into SOLIDWORKS Simulation Standard to help see a little bit about what's going on inside my design. Now what I'm going to do next is I'm going to go through and I'm going to optimize this even more to create a little bit better. I'm going to play around with different wheels, I'm going to play around with different things to see if I can't get a little bit more speed out of this car, so it's guaranteed that I'm going to win every race. Thanks again for tuning in. Hope this has been informative for you guys, and until next time.